All right, so today we are going to talk about chapter 10, which is the process of hypothesis testing regarding different parameters. So we will discuss what hypothesis testing is and then go through examples with both proportions, means, and standard deviations. The first section, we have to just discuss what really is hypothesis testing. How do we determine a null and alternate hypothesis? I'm going to discuss a type 1 and type 2 error, and then how we write conclusions to our hypothesis tests. I'm going to start with an example here. A friend of yours wants to play a simple coin flipping game. If the coin comes up heads, you win. If it comes up tails, your friends win. Suppose the outcomes of 5 plays of the game is tail, 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 tail. Is your friend cheating? Okay, well, we can figure out the probability of getting 5 tails in a row. We did this back in chapter 5. The flips of the coin are independent, so all we're going to do is figure out the probability of tail, followed by tail, followed by tail 5 times. 5 tails in a row is T and T and T and T and T. And the probability of each T is a half. And we're going to multiply those all together. So the probability that this would happen would be 0.03125. If we flipped a fair coin 5 times, 100 different times, what that means is about 3 of the 100 times we did this, we would get all tails. So what we observed is possible to happen, but not entirely likely. So what can happen is we have 2 conclusions that could happen. One is that our friend is not cheating and just truly happens to be lucky. That because this is possible, it is possible to happen, they just got extremely lucky. The second option, because it's not very likely, is that they are not using a fair coin. So maybe they have a weighted coin that is going to make the tail side come up more common or more frequently than half of the time. This is basically the process that we're going to follow kind of for hypothesis testing. We are just going to determine through probability what type of a conclusion we can make. So in this case, our decision would be, is our friend cheating, or did you just happen to experience an unusual result from a fair coin? This is truly the heart of hypothesis testing. That's what I was trying to say. We make an assumption about what we believe to happen or from prior research. Our assumption is that in general, it should be 50-50 to get a tail. And then what we're going to do is we're going to gather another sample set of evidence and determine whether that contradicts our initial assumption. So there's 2 assumptions here. We have the null and then our alternative. So anytime we want to perform a hypothesis test, we are going to have to create 2 hypotheses here. So what is a hypothesis? Well, it is a statement regarding a characteristic of one or more populations. So the characteristics we are going to be working with are P, mean, proportion, mean, and standard deviation. Okay, or proportion, population mean, and population standard deviation. Chapter 10 is all about single parameters. So a single proportion, a single mean, a single standard deviation. And then we're going to use this process of hypothesis testing which is a procedure based on sample evidence and probability used to test our statements regarding that characteristic of one or more populations. So this chapter is going to be one sample, and then next chapter is going to be 2 samples. Okay, so the way hypothesis testing works is we are going to make our statements, our null and alternative hypotheses. You then collect evidence from a sample, and then we are going to analyze the results based on probability and create our conclusion. Just remember that we are working with samples here. So our null is an assumed statement. And when we use a sample, we are only collecting a portion of the population. So we can never, ever claim 100% certainty or ever make a statement that one of the hypotheses is true. And we'll talk about that a little bit more as we get going through this process here. All right, a null hypothesis denoted by H sub O, is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed to be true until evidence indicates otherwise. All right, so again, we are assuming this to be true. We cannot say ever with 100% certainty that it is true. We will discuss that a little further, but we're basically going to say we have enough evidence or we don't have enough evidence to kind of make one of these claims. All right, our alternative hypothesis denoted H1. Sometimes I will do H sub A for alternate. That's just the way that I was always taught. So I kind of default there by habit. But H1, H sub A, whichever one you use is going to represent the same thing. This is the statement that we're trying to find evidence to support. So we have our null statement. This is what we know to be true. And then our alternative is, hey, what do we think is happening now? There are 3 ways in which we can set up these hypotheses. All right, every single one that we do, the null hypothesis is always going to look the same. It is the alternative that has 3 different ways to set up. The first test here is equal versus not equal. We are told we knew the proportion of heads to tails in a fair coin is 1/2. I want to know if based on my first example we looked at is that the proportion of this coin's heads or tails is not equal to 1/2. So then I run some tests and I'm going to see it's not equal to it. Maybe it's bigger, maybe it's smaller. Option 2 is an equals test versus a less than test. So maybe I had some information that said the average wait time to get your food at the local Wendy's was 5 minutes. Okay, my Wendy's is super slow. Maybe the manager decides, okay, we're going to employ this new process, and I think I can now reduce the average wait time to less than 5 minutes. So, example for that one. It equals to versus a greater than. So maybe we have our average sales are equal to however much. And I'm going to run some advertisement, and I believe that my sales are going to be greater than that value this next month. Okay, so we can test 3 things. We can test that the value is no longer equal to what we had assumed, the value is now less than to what we had assumed, or the value is greater than what we had assumed. So 3 ways in which we can create our hypotheses. In other words, our null hypothesis is a statement of status quo or no difference. It always contains a statement of equality, all right? It's always going to say P equals some number, or mean equals some number, or standard deviation equals some number. Always going to be in the form of an equals to. The null hypothesis is always assumed to be true unless we have enough evidence to claim the contrary. So we're going to seek evidence that supports the statement in the alternative hypothesis. That's our goal. If we're thinking, hey, it's now different, or it's less than, or it's greater than, our goal is to see, do we have enough evidence to make that new claim? Because we have to go based off of our null hypothesis, which is already assumed to be true. Do we now have enough evidence to say that it isn't what it was previously thought to be true? Anytime you do a less than or a greater than test, they are considered one-tailed tests because I'm only checking one way. I'm checking smaller or I'm checking bigger. Versus a not equal to is testing both sides, greater or smaller. Notice in the left-tailed test, the direction of the sign goes to the left, left, less than, or left arrow, left, less. They all go together. Which means then the right is going to be greater than, right? If you turn it into an arrow, looks like it's pointing to the right. Okay, in all three tests, the null hypothesis contains the statement of equality. So again, just reiterating that the null is always an equals to statement. How would we determine which hypothesis we are working with here? Well, let's take a look. The Medco pharmaceutical company has just developed a new antibiotic for children. 2% of the children taking competing antibiotics experience headaches as a side effect. A researcher for the Food and Drug Administration wishes to know if the percentage of children taking the new antibiotic who experience headache as a side effect is more than 2%. Your first thing is you have to determine what symbol are we working with. Are we working with a proportion, a mean, or a standard deviation? Because we have percents, we're working with proportions. The hypothesis deals with a population proportion, or a p-value. So what we have to do is we have to assume, based on what we know, that the initial proportion is equal to 2%, or 0.02. Remember, you can take 2%, which is 2 divided by 100, to get the decimal form. This is our equals statement, our statement of no effect, no change, the status quo. This is what we know to be true previously. Our alternate is what we are trying to show or claim now. So the researcher wants to know if the proportion is more than that 2%. So I'm going to use a greater than 0.02 because they want to know, is it more than that value? And that is all here as well, explained just in the book's terminology here. This is a right-tailed test because the alternative hypothesis contains a greater than symbol. So a right-tailed proportion test. The Blue Book price of a used 3-year-old Chevy Corvette Z6 is $59,083. Grant wonders if the mean price of a used 3-year-old Chevy Corvette Z6 in the Miami metropolitan area is different from that value of $59,083. It clearly says mean. It clearly gives you the number, and then it clearly tells you what they want to test. The hypothesis here deals with a population mean or mu symbol. We are told that the mean is equivalent to that $59,083. That is what we are told. Grant wants to see if in Miami it is different from that. So different, then that means I'm going to test either more or less, which is not equal to the value. And that is the alternate hypothesis. Anytime we do a not equals to test, this is a two-tailed test. We are testing smaller or bigger. And we are testing a mean. And then by process of elimination here, we'll do the other one. So the standard deviation of the contents of a 64-ounce bottle of detergent using an old filling machine is 0.23 ounces. That is what the standard deviation is. The manufacturer wants to know if a new filling machine has less variability. So we want to test less than this value. This one we are working with a population standard deviation or the sigma value. And based on what we know, it is currently equal to, 0.23 ounces. Okay, he is going to install a new machine and run the test again. And he is hoping that it is now smaller than 0.23 and that his values are even closer together than they were, that there is less variability than he had previously. Same for the values here. This is a less than test, so a left tail or a one tail, and we are doing a test on standard deviations. What we're going to look at next here is what happens when we run a hypothesis test. Okay, anytime we run a hypothesis test, there is a possibility that you make the wrong conclusion. Okay, that's why we always follow a specific process to make sure we make the correct conclusion. The thing is, you may not know if you made the mistake until you really practice enough. Always, always, always go back to follow the steps to try to make sure that you don't make one of these errors so that you do make the correct conclusion. 4 things that can happen. Option 1 is you reject the null hypothesis when the alternative hypothesis is shown to be true. That would be correct. If we have enough evidence to show the alternative has happened, we have to reject the null hypothesis. That is a correct conclusion. We do not reject the null hypothesis when the null hypothesis is true. This would be correct. We run the test, and we do not have enough evidence to show that anything has changed. So at that point, we cannot make our new claim. We are not going to get rid of our null hypothesis, and that would be correct. Now, here is where we make a mistake. I say I'm going to reject the null hypothesis when in fact I shouldn't have. If you say you reject the null hypothesis when we had evidence to say that it really was still true, this is incorrect, and we call this error type 1. The last one is we don't reject the null hypothesis when we have enough evidence to show that the alternative was in fact true. Again, this would be incorrect, and this would be what is called a type 2 error. Here's a little visual example. We show here that our null hypothesis is true. We did not prove any sort of differing from our null hypothesis. The correct conclusion would then be, do not reject the null. The incorrect conclusion is to say we do reject it. If the alternative is true, this is when we have our evidence. We've shown it is not equal to, greater than, or less than. Our correct conclusion is to then get rid of the null hypothesis. If we didn't do that, we would be making an error. For example, thinking to maybe something that's a little easier. Example here. In the court system, the null hypothesis is you are innocent. It is always innocent until proven guilty. So your alternative is guilty. Let's think about it here. So innocent person versus guilty person. If you are innocent, the correct conclusion is to not reject the fact that they are innocent. That they are correctly innocent. Innocent, this would say guilty. If they're innocent, they should be innocent. That is correct. If you claim that an innocent person is no longer innocent and that they are guilty, you have made a wrong assessment. If they were truly innocent and you send them to jail, that's not correct. They were innocent. So let's say we have a guilty person and you then claim that they're innocent. Well, that is false. That's not true. You made an error. The guilty person is in fact guilty. So it's all about making sure we understand the process, how we write our conclusions. Again, there is a whole step process that we're going to follow to try to make it a little bit easier. The Medco pharmaceutical company, with that new antibiotic, we said the old antibiotics had a 2% chance of getting a headache. And they want to see if it's now more than 2% with this new drug. So we had our initial hypothesis here that what we know is that every other antibiotic has a proportion of 2% for headaches. And we think this is now more than 2%. What would it mean to make a type 1 error? Well, I kind of want to think, I can think back to that kind of table thing here. So P equals 0.02, P less than 0.02. Nope, greater than. This is do not reject. This is reject. So the type 1 is down here. The type 1 is when we reject the null hypothesis when we shouldn't have. The type 1 error is made if the sample evidence leads the researcher to believe that it is in fact greater, rejecting the null when in fact it really is not greater than 2%. Type 1 means we reject the null when I shouldn't have. Type 2 error is when I do not reject the null, when in fact I should have. Okay, so a type 2 error is made if the researcher does not reject the null, that the proportion is equal to 0.02, when in fact the proportion is greater. So type 2 is when you claim do not reject when I should have. An error is when you make the wrong conclusion. How do we make conclusions in these hypothesis tests? Well, first off, we have to make sure we never say, we accept the null. We cannot say that. The wording of this process is extremely important. We cannot accept a null hypothesis because all we have done is taken a sample. If I do not access the entire population, I do not know the full population value. Again, mine is an estimate that can be within a certain range based on my confidence intervals that we just did. We either say reject or we do not reject. So either we have enough evidence to make this new claim or we don't have enough evidence to make this new claim. It's for the same type of thing with the court system. You have the terms not guilty and guilty. They do not use the term innocent in the actual courtroom. They claim not guilty. They don't use the term innocent, they use the term not guilty. Not innocent and not innocent, it's not guilty and guilty. How would we state our correct conclusions here? Again, using that same example of the Medco, pharmaceutical, antibiotic. So null is that the proportion of headaches is 2%. Alternate is that the proportion is greater than 2%. Suppose the sample evidence indicates that the null is to be rejected. How would we write our conclusion? Well, if we reject the null, the statement is then that the alternative is that the proportion of children taking the new antibiotic experience a headache as a side effect is in fact more than 0.02. If we reject the null, we are able to claim P is greater than 0.02. So this statement right here then is how we write our final sentence. There is sufficient evidence to conclude that the proportion of children who experience a headache as a side effect is more than 0.02. The only thing you need to know is this part here. If you reject the null, there is enough evidence to conclude whatever the claim was. The proportion of those getting headaches is more than 0.02. If we do not reject the null, we're going to go here. We do not reject the null. There is not enough evidence to claim that the proportion of children who experienced a headache is more than 0.02. So no matter how you do this, it's either there is or is not enough evidence to say the fill in the blank with the claim. There is enough evidence that the mean is not equal to something, or there isn't enough evidence to say that the mean is not equal to something. That is the basis for how we're going to write our conclusion. All right, so that is the end of this section. As we go through this, we're going to do the whole entire process of a hypothesis test for each of the different variables. I will see you then in the next video.